Dear colleagues, let me present the results of our scientific work. The presentation structure has been depicted on the second slide. The modern system requirements development process is based on the principle analyze, structure, formalize. Slide number 2, 3. As we can see, to prepare requirement specification, we need to prepare three components: user stories, UML diagram, and a formal description of the future system architecture. By the key is that the conditions under which we do this are becoming more stringent due to competitive pressure. In the marketplace, it is not the big and small that die, but the slow ones. Time and quality factors are becoming paramount. This means that the current situation forces us to prepare requirements as quickly as possible. But we also need to perform a formal verification procedure to confirm the quality of the system requirement specification. Consequently, we are faced with a new market situation. Slide number 4, which introduces three new factors. First, as IBM research has shown, approximately 50% of all errors are hidden in requirement specification. A time, as we discussed above, is a critical factor. Second, when formulating requirements, we go through the stages of interviewing, structuring in diagram, and preparing for testing. And we want to have clear, understandable algorithms, so we know where and at what stage we are likely to have made errors. Third, modern programming methods make extensive use of patterns. This includes patterns in the development process itself, as well as patterns in program code or test plans. However, accessible system requirement specification patterns are not yet available. As we see, answers to posed questions risk can be obtained using generative AI system, artificial intelligence system. In this paper, we briefly reviewed recent scientific articles on the use of AI for creating system requirement specification. Slide number 5. We found that over the past 3 years, there has been significant interest and practical implementation of system requirement specification patterns. Active work is underway in this area. However, all current research is still in the experimental stage. That is, there is no completed research and no stable design patterns or system requirement specification patterns for various types of software. The main advancement that has been made in the development of guidelines for preparing so-called technical proposal for generative AI system. Our research team is also actively working in this area, but in different research areas. However, the research of requirements preparation overlaps with our previous research project in the area of applying generative AI to the synthesis of semantic kernels. Since both projects require text processing, we would like to share our vision for solving this problem. Slide number 5. We believe that any artificial intelligence system must be taught to correctly execute an algorithm or solve a given problem. To do this, we need to conduct a series of experiments and, based on these experiments, propose an abstract mathematical model of the requirements preparation pattern using generative AI. Slide number 6. We consider three sets of input information for generating a requirement specification. First, these are the text received from the customer. Second, these are the documents the customer is willing to provide us with. Third, these are the constraints that clearly exist in the given subject area. In other words, we are compiling a knowledge base for the subject area in which we will develop the system requirement specification. The expected outputs is a set S itself, which describes the specification. Slide number 6. Given the inputs and output information, we construct an abstract for function f, which in our case serves as a prompt for generative AI system, formula 3. We understand that generative AI can generate requirements in an unstructured form. Therefore, we need to obtain a formalized response from it, formula 5, and also verify the resultant requirements, formula 7, this slide 7. As can be seen from the abstract model, slide 7, we need to propose a clear and understandable requirement generation algorithm, which we represent on the next slide, slide 8. We conducted a series of experiments, approximately 60, using the specified requirements preparation framework. The experiments algorithm remained the same. Slide number 8. It is shown in more detail in slide 9 here. As we can see, the primary focus was on 3 elements: user stories, UML diagram, and a mock-up of the future software system. Our experiment showed that the last elements was very important to the client. They wanted to visually envision how the software system would look. As we understood, it was important for the client to mentally simulate the behavior of the software system. Slide number 9. We conducted 2 sets of experiment. The first set, slide number 10, involved manually preparing requirements in 3 areas according to our algorithm. In both the sets, our analyst prepared the same software system for automating the process of choosing a pet's diet. The second set of experiment, slide number 11, involved using ChatGPT to prepare requirements. As we discovered, thanks to our interaction with ChatGPT, mockup became unnecessary. Generative AI, through the preparation of prompt, allows us to simulate the behavior of the future software system and immediately generate program code and output data formats. The slide shows the resulting file in JSON format. This means we see a 20% reduction in time, and most importantly, the customer immediately receives a simulation of the software system behavior at the most important point, the delivery of the software system primary output. In the last slide, we propose future research work or future research areas, such as creating a specified training model for generating requirements in Python, but locally. Secondly, we also need a trained model for generated UML diagrams. Thirdly, probably, we would like to expand the experiments for model training. It would be useful to conduct experiments online rather than locally. In other words, we should propose beta testing session. Thank you, colleagues, for attention.